If we were to make a graph plotting the energy as a function of distance that the spring is stretched from 0 to whatever that max was, I think it was 5.1, so we'll put it in right about here. What will we find? Recall the total energy in the beginning was just the energy of the car, 200,000 joules. So if I start by plotting total energy, 200,000 joules, I want to make a line for total energy. How would that look? If that was what you were guessing, you are correct. Now we plot the kinetic energy. Starts out at 200,000, and it's not linear. Ends at 0. So our kinetic energy is 0 at the end. That's when the spring is compressed the maximum amount. The car stops, so the kinetic energy is 0. Let's label the total mechanical energy, ME, which leaves the potential energy. How does the potential energy look on this graph? And we're talking about spring potential energy. How would you fill it in? Where would you start? 0, middle, up here? 0 is correct. When the car is reaching the spring has no potential energy. The spring, now I'm not going to get this exactly right, but in general, the graph is going to look like this. We'll label this line potential energy, spring potential energy. Now, if I did this correctly, somewhat correctly, hopefully, if I look at, let's say, 2.5 meters, and if I look at any distance that the spring is compressed, then if I look at the potential energy in the spring and add the kinetic energy in the spring, what does it add up to? 200,000 is correct. In fact, anywhere, this looks like I did all right here, as the kinetic energy and potential energy are both about 100,000, so if you add them, they add up to 200,000. So as the car is slowed by the spring, the potential energy in the spring increases. And this is the kind of thing that happens in all of these energy transfer problems, where one type of energy is increasing, but if conservation of energy is true, another type of energy must be decreasing, conserving energy overall. Now this is the case again where there's no friction. No friction means kinetic energy plus potential energy is conserved. So make sure you understand these energy plots and how potential energy, kinetic energy, mechanical energy all relate.